Hi, I'm Zilin, and this is the milestone 2 for SE576. I will start by showing the convert project. Let me first run the converter on the release mode. Okay. Instead of converting meshes for every bone in the models for milestone 1, we use the converters joint and converter skin method to generate the skin and joints information with the data and also skeleton data. Together, we can produce the skin-based animation using the linear blended skinning formula. So now I converting the animation-related photo buffer files for chicken boat and convert chicken boat mousey and the spider boat. All the other buffer files remain the same as the milestone 1. Okay, all the photo buffers has been generated. Let's move on to the engine part. Let's first run the code in debug mode. You can see the mousy chicken boat and the spider boat animations. They all use light texture skinning. You can press the space key to switch to different animation. And now let's exit it. As you can see, there is no memory leak. Next, we switch to release mode. As you can see, it's also run perfectly. Okay, in milestone 2, we use a different way to create animation. First, the normal texture creation. Then we deserialize the mesh proto buffer and create the join table. After that, we load the skeleton information as well as the animation clip. And then we use this data pattern to create the animation objects. This allows us to generate skin-based animation. Then we can go into the anim class. Anim class, the critical part is uh, generating a skeleton instance. Uh, in skeleton, where we build the animation hierarchical structure. As you can see, we use the graphics object skin light texture as the rendering method. Since all the bones here are invisible, we use now game object, now graphics object for them. And also this skin light texture graphics object requires corresponding shader object to apply the lighting effects. So we add the uh, skin light texture shader. We need to provide extra data field, the normal, and also the light position and the light color to the graphics object. And I also added the shaders here. The shaders skin light texture shader for the light texture skinning. One important thing to note here is that I use the same principle as the vertex position for the vertex normals. I apply linear blending skinning to the normals by rotating them with each bone and then renormalizing them to ensure correct lighting. Yeah, and for these shaders, I also added a shared header file here to organize all the data structure definitions. This allows the shaders to define their data. Only use the macros, simple macros, so the definition can be consistent. That's it for milestone 2. Thank you.